The human-machine interface that you use is an incredibly powerful device. They are not just used for the pretty pictures and the alarms as well as the trends. In this video, I'm going to actually show you how you can use scripting to calculate important information. I have a nice easy configuration up on the screen. I've got 3 analog values that are going to come into the system. And if I was just to go and demonstrate that, on the very left hand side we're going to have the line voltage, and that line voltage can go from 0 up to 1000 volts. In the center I'm going to have the line current, and in this case I've set it to go from 0 up to 500 amps. And last but not least, on the right hand side I'm going to have the power factor. Now unity power factor is typically going to be at 1, and that can go down. Of course, the worse the power factor, the worse your real power is going to be. Now what we want to do is we want to calculate the real or the true 3-phase power that I have gone and put in at the top. And you literally have to take the information that you have got and do a calculation and get the right values. Now I'd like to give you a little bit of electrical theory on this just to put it all into perspective. On the screen, I've gone and drawn the power triangle. Now, for most of us, we would know the angle as being the angle theta that we have gone and put in. Now, if you look at a triangle such as that, and if the triangle is going to have a right angle on the right-hand side, then at the bottom, where we have the real power, that's often going to be known as the real or the true power. Let me go write that in over there. That's going to be the real or the true power. And that is typically going to be calculated as the square root of 3 V line I line times the cos of theta. Now, if you look at it from a trigonometrical point of view, that is going to be known as the adjacent. So let's go and put in there the adjacent. On the right-hand side, we're going to have the reactive power, which is calculated as the square root of 3 V line I line times the sine of theta if you're working with a 3-phase, and that is going to be known as the opposite. And then the diagonal that we see on the left-hand side is going to be known as the hypotenuse. And let's just go and put that in. Now, when it comes to trigonometry, always interesting that you can have various ways to remember the equations and the formulas. One that was taught to me a couple of years ago was some old horses can always hear their owner's approach. Now, if I'm thinking in terms of the cosine of theta, and I happen to have the adjacent and I happen to have the hypotenuse, then I can go and do a nice easy calculation based on that. So I'm going to go and use this formula over here to determine my angle theta that we can go and calculate. We know that the cosine of theta is going to be the adjacent over the hypotenuse, and in our case the adjacent that we are going to have is going to be the real power divided by the apparent power. And all that you need to do is to take that formula a little bit further, which I will do on the next page. So expanding this a bit further, we already do know that the real power is going to be calculated as the square root of 3 multiplied by V line multiplied by I line multiplied by the cosine of theta. Let's just go and write that in. That's going to be equal to the square root of 3 multiplied by V line multiplied by I line multiplied by the cosine of theta. We're trying to calculate what we are going to go and get in this particular instance itself. We do know that the apparent power is going to be calculated as the square root of 3 V line I line, and that would be the easiest formula to get that. And of course, we're going to have certain values that will cancel out with each other, and that's going to leave us with the power factor, and the power factor is going to be the equivalent of the cosine of theta. Remember, the power factor is going to be that angle that we have over there. So the power factor is going to be related to theta, and it's going to be the cosine of theta, and that's the way that we're going to go and use it. Now, I can take this information and I can put this into my script for my HMI. So on the far right hand side, you can see that my power factor is already calculated from the cosine of theta, and that's why it is going to have a value that's going to range from 0 to 1. And now it becomes very simple. If I was to go and read my voltage, read the current, read the power factor, and put that into an equation, I'm going to use 1.73 multiplied by those three values. And if you're wondering where I get the 1.732 from, that is the square root of 3. The square root of 3 is 1.732. So I'm going to multiply that value with the voltage, the current, and the power factor. And of course, dividing it by 1,000 is going to give me a value in kilowatts. And all that remains for me to do is just to go and pick up the value that has been calculated, the real or the true power, and to go and display that on the screen itself. And you can actually see now, if I was to go and decrease my voltage, my real or my true power is going to decrease. Or if I was to increase the current, then that should increase. And if I was to take my power factor away from unity, a lower value, my power is also going to decrease. So very, very powerful tool that you can use to go and do scripting inside your human machine interface. There's a lot more to these devices than just the alarms and the trends and the pictures. As always, be sure to enroll yourself for one of these courses where you'll learn all of this as well as a lot more.